great to be here. Hello, everyone. I'm also going to go ahead and share my screen so you can see the presentation. Let me know if that works, but should be fine. Okay, perfect. Then, yeah, let's get started. I'm Ida. I'm the founder and CTO of Alteva. And at Alteva, we build the future of batteries. For us, that means next generation batteries made here in Europe. And to start off, let's just remind everyone here in this call, we're all working on one of the biggest engineering challenges of our time. Like we're developing materials on a molecular level that have to work on a microscopic scale, but at the same time, we want to produce billions of batteries. And to be honest, I think that's a pretty cool topic to be working on and challenge to be tackling. So that's really what we want to do at Alteva. So what we do really is we take these next generation battery technologies and make them scalable. Basically, take what we have in the lab now and then step by step go into larger scale production until we reach these gigascale factories. Because that's really what we think we can make a difference on here in Europe if we have domestic battery production again. And the kind of technology we're looking at for these next generation batteries is especially lithium-sulfur batteries. I'm not sure how many people here are familiar with that technology. There are quite a lot of advantages to using lithium and sulfur as the chemistry of batteries compared to current lithium-ion batteries. The first one is around materials. We actually have materials that are very abundant and available. Sulfur is one of the most abundant elements in the world. It's a waste product in a lot of industries, so it's cheap and easy to get, also here in Europe. Lithium is also not that much of a problem. So all the things we can get basically here in Europe, lithium, we have to open the mines, but this is possible compared to, for example, sourcing cobalt from Congo and so on. We don't need that anymore. The second big advantage of lithium sulfur is that they're only 1/3 of the weight of current lithium ion batteries. So all the applications where weight is crucial can massively benefit from us using lithium sulfur batteries. And those of you who are familiar with lithium sulfur probably also know the challenges why we don't see that in the market yet. And that is mostly around the lifetime of these batteries. So lithium and sulfur right now can only last like maybe 50 cycles if you're lucky in a lab. There are some developments going on, but what we really have developed and what makes the difference is that we have a cathode material that stabilizes the sulfur in a way that we can make it last hundreds of cycles to really make it competitive to lithium-ion batteries. And that's our core competence. So what we do at Alteva is that we have this cathode material and we produce batteries of these next generation batteries at scale. So basically from lab scale all the way up via prototypes to now pilot scale production that we're setting up at the moment, up to step by step onto gigascale. And with our competencies being around the cathode and production, there are also some other aspects that we basically, also use the network that we're building here in Europe for competencies around, for example, lithium metal anodes. So we're working a lot on lithium metal batteries as well, just to get the handling done and so on, because there are really not that many people who can actually build lithium metal batteries at scale. And that is the know-how that we're building at Alteva to really get these next generation technologies into large scale. Because let's be honest, like there isn't much of a case for us to compete with China on prices for LFP batteries and so on. So if we really want to build the future of batteries in Europe, we need to focus on these next generation batteries. And that's what we do at Alteva to really make that happen. So if you're interested in supporting us, be it if you're like best talent and want to support us in building this company, if you have a great material, be it an electrolyte or a separator that could be interesting for our technology, we are always also looking for collaboration partners there. Or the last part definitely is like if you want to support us in funding this kind of new next generation production infrastructures, please reach out. We're looking forward to working with all this network that we have here in Europe to really make that happen. So looking forward to your questions. Thank you.
Thank you very much, and perfectly on time. That leaves us a lot of room for questions. As I mentioned, if there are questions from the audience, put them in the chat, raise your hand. We have already one question in the chat. Michael, if you want, unmute yourself, ask the question directly. That's always better than me reading it out.
No problem at all. Hello all. So I'm in the field of clean room technology and building fabs for production of batteries. Therefore, my question is, if the production of lithium-sulfur batteries have different needs for the environment, for the production environment? Is there another dew point or another level of cleanliness, or is it with another atmosphere?
Good question. Like, I'd separate like the requirements out for cathode and anode. On the cathode side, our material actually really is a carbon-sulfur composite. So no materials that are at all like sensitive to moisture there. We actually use water-based coating systems on the cathode, which also makes scaling much easier. On the anode, we use lithium-metal technology. So there we have kind of the same requirements as any lithium-metal battery. So dew points, like at least -40 definitely is what we need to build the battery cells.
Okay, thank you.
Yeah.
All right.
Maybe also a question from my
Yeah,
if I may.
go ahead.
Just curious. Amida, can you elaborate a little bit on the technological status that you're in? Are you rather on lab scale still, or are you piloting? Like, where is your innovation path going right now?
So at the moment, we're kind of like prototyping in the lab still. So our current production capacity is around 40 cells a week, what we can do if we max out our production infrastructure right now. But we are also right now already in the planning phase for our pilot production, which will be more in the vicinity of 200 to 300 cells a day, which we are setting up, basically middle of next year. That should be operational. So that would get us like in the middle one digit megawatt hour range to like start scaling production. As I said, we have the step-wise approach. We're not building the gigafactory right away, and so we have this pilot facility coming up, and then basically scaling every 2 years, factor 10 to 20, to really get that production know-how on a path to large-scale production.
Okay, yeah, I gotcha. Perfect, thank you.
Yeah, maybe especially since our next speaker will talk about transport and storage, could you maybe comment? I mean, as a chemist here, sulfur, it always like flammable reactions always pop into my mind. Could you maybe comment on the safety, especially for like the transport applications of your battery system?
So sulfur has one advantage over lithium-ion batteries, that we don't have oxygen in the battery cell. So if there are internal reactions happening with the lithium and sulfur still react, they release energy, but it's not as explosive in reaction as you would see in a lithium-ion cell when you have the lithium metal actually reacting with the oxygen that is released from the cathode, which makes the batteries inherently safer than lithium-ion batteries. So like a lot of these safety certifications and so on are a little easier to get. So like I wouldn't say they're perfectly safe, but they're definitely improvements over lithium-ion technology. And then we're also, for example, looking at non-flammable electrolytes, which can even improve the safety further, to make transportation and so on even easier.
All right, thanks. Yeah, I have to say, very interesting technology. I hope that the scaling up and the piloting phase will go well. You already said with your call to action, you're looking for a lot of different partners helping you. Maybe a quick comment on the investment part. Are you actively looking right now for investors, or are you set right now for the future?
We're basically preparing our next financing round at the moment. So the next step will be financing the pilot facility. That will be classical venture capital for like the startup financing, but we're also looking at grant options and debt options. So getting all that financing together to set a production like that up. That's what we're working on at the moment. Yes.
All right. So to all participants who has some money lying around, contact Ida. And Ida, with this, thank you very much for your pitch. We are moving to the next speaker. And Simon, please introduce him.